So a thin vertical plate of height L and infinite width is perpendicular to the figure. Okay. Yeah. Infinite width perpendicular to the plane of the figure is losing heat to the surroundings. Yeah, is losing heat to the surroundings, and the properties of the surrounding fluid are constant. The relationship between average Nusselt and Rayleigh number is given as Nu is equal to K into Ra raised to 1 by 4, where K is a constant. The length scale of Nusselt and Rayleigh numbers are height of the plate. The height of the plate is increased to 16L, keeping all the factors constant. The height of the plate is increased to 16L. If the average heat transfer coefficient of the first plate is H1, then that for the second plate H2 is H2. Then the value of H1 by H2 is fantastic. Fantastic. One mark only. One mark. You know what is Nusselt number and Rayleigh number? Done. 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 Nothing great. Rayleigh number is Prandtl and Grashof. You should know what is Grashof. That's it. In Grashof there is L. In Nusselt number also there is L. So things becomes very easy, students, when you know the things. Only problem is recalling this in Gate. That's the only problem. Now that this much is done, where is the mechanical? This kind of one book I have to bring. Who will help me out in that afterwards? In typing this, if you help me out, okay, and doing it without any this one, without any plagiarism. You should not copy from someone. I'll give you the what you say. One you have to do afterwards, after your git. Yeah, I'll give you. You are my partners there. Understand? You have to do separately. You have to type and give me. It's for long run. Okay. No, all things goes in partnership only. Here also it's partnership. Whatever the what to say, earning we have, yeah, simple and straight. For lifetime. Simple. Whenever it goes to you. So, anyhow, chalo. Do it first. Same thing happens with our teachers also, is it not? With my teachers also same thing happens. They are all my partners. Although it is owned by me, in terms of this one, it's all partners. Fantastic question in 2022. Is it two? Okay, let us see. Correct. इतना इजी सटासट हुआ. तो क्या करना है यहाँ पे? नसल्ट नंबर इज HL by K is equal to K is the Rayleigh number. Rayleigh number K you keep it constant. Rayleigh number is, what is Rayleigh number? Tell me. It is function of L cube raised to 1 by 4. And L has to cancel over here. Very important. Okay. So what is the Grashof number? Grashof number we have taken as G beta. We can take it, right? G beta, so that will there is a repetition. Okay. So K into G beta T minus T infinity, correct? TW minus T infinity, TW minus T infinity, L cube divided by nu, right? Remembering is important, raised to 1 by 4. Huh? Nu square. Remember, I am very bad at remembering. You saw, okay? But don't see when we do it like that, then only you get. So whenever you are here, you see that this has to be remembered. Next, in the whatever be this, okay. So yeah, this is how the things are, okay. So yeah, when so L is here, so it becomes 2L, 16L. So it becomes 16L. This becomes K, okay. It's equal to G, so L by 16L. So we can write this as H1 16L. Yeah, yeah. Wait a minute. H1, okay, L divided by H2 16L is equal to this. All those things will remain. L cube 3 by 4, L raised to 3 by 4. Here 16L raised to 3 by 4. That's it. So this way you have to put it nicely. So you'll have H1 by H2 is equal to 16 into L raised to 16 by 16 to the power 3 by 4, and then here these cancels. So right, no, so this becomes L raised to 3 by 4, this becomes L raised to 3 by 4, cancel this. So H1 by H2 is equal to 16 by 16 cube and 4th root, or use a calculator. 3 by 4 is very, if you cannot think about it, yeah, 16 to the power 1 by 4. So here you will get, yeah, 3 by 4. So 16 raised to 1 minus 3 by 4. It is 16 raised to 1 by 4. So 4th root of 16, which is 2. Easy. So 2, 2, 2, 2, 2. Okay, next question has come in 2022 itself. In 2022, there were a lot of questions on heat transfer, and most of them were on these things only. So let us go with 2020 first. Let us go with 2020 first. Very easy questions. So we'll go with 2020 first. Then we will go with 2020, then 2021, then 2022, 2020. Okay. So mechanical engineering. Okay. 2020 mechanical engineering match. Let us have a match. No, there is no match. Okay. So set one. So we have to go like this only. No, not this. This. Yes, this is 2020 gate. Okay. Can you do this? This kind of question, when it comes, no, you'll feel very, very happy. Is it not? Why not? I have to say you that, say, if I don't do these things, you will not know that easy questions also comes in gate. So you'll think gate is all difficult questions. Is it not? Tell me the answer. Do you need anything for this? No, right? This has come in 2020 gate. Hi, here you are going. This comes as 2021 mark, set 1. Reynolds number is inertia force by viscous force, correct? Yes, Sujit will tell me. Grashof is Nusselt, and then Prandtl. is moment of diffusion. Okay. So now, as we have done this, it seems so easy, so silly, is it not? Next. Next comes is 2020 only, but yeah, that is not related to. Yeah, that let us leave it. Okay, we are going to 2022 directly. 2021 there were no questions on this topic, but 2022 there was a topic. There was a question. 2022 mechanical engineering. So here set one, set one. This is ಹೇಳಿ ಮಾತ್ರ ಸುಜಿತ್ ಹೇಳೋದೇ ನಾನು ಕೇಳ ಹೇಳಪ್ಪ ಸುಜಿತ್. What Sujit says is the right answer. ಸ್ವಲ್ಪ ಮಕ್ಕರ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ, ಬೇಜಾರು ಮಾಡ್ಬೇಡಿ ಆಯ್ತಾ. You're having some fun at your expense. Okay? Yes, tell me what sense. ನೋಡಿ ಅದಕ್ಕೆ ಇದೆಲ್ಲ ಈಕ್ವೇಶನ್ಸ್ ಮಾಡೋದು ಎಷ್ಟು ಇಂಪಾರ್ಟೆಂಟ್ ನೋಡಿ, ಅದಕ್ಕೆ ಡಿರೈವ್ ಮಾಡಿದ್ದೀವಿ. ಯಾಕೆ ಡಿ ಗೊತ್ತಾ, ಇದು ಮಾಸ್ ಇಂಟು ಆಕ್ಸಲರೇಷನ್, ಯೋಚನೆ ಮಾಡಬೇಕು. ಇದು ಮಾಸ್ ಇಂಟು ಆಕ್ಸಲರೇಷನ್, ಮಾಸ್ ಇಂಟು ಮಾಸ್ ತೆಗೆದಾಕಿದ್ದಾರೆ. ಸೊ ಏನಾಗುತ್ತೆ, ಇದೆಲ್ಲ ಫೋರ್ಸಸ್ ಆಗ್ಬೇಕು. ಇದು ಫೋರ್ಸ್ ಯಾವುದರಿಂದ ಬರುವುದು, ಇದು ಫೋರ್ಸ್ ವಿಸ್ಕಾಸಿಟಿಯಿಂದ ಬರುವುದು. ಸೊ ಇದು ವಿಸ್ಕಸ್ ಫೋರ್ಸ್ ಪರ್ ಯೂನಿಟ್. ಇದು ಆಕ್ಸಲರೇಷನ್ ತಾನೇ. ಸೊ ಹಾಗಿದ್ರೆ ಇದು ಆಕ್ಸಲರೇಷನ್ ಆಗ್ಬೇಕು, ಇದು ಆಕ್ಸಲರೇಷನ್ ಹೌದಾ, ಸರಿ ಅಲ್ಲ ಅಷ್ಟೇ. ಸೊ ಆನ್ಸರ್ ಇಸ್ ಡಿ. ದಟ್ ಇಸ್ ಇಟ್. ಇಟ್ನಾ ಈಸಿ ಸಟ್ ಅಸಟ್ ವಾ. ನೆಕ್ಸ್ಟ್ ಕ್ವಶನ್. ಬರಿತಾ ಇದ್ದೀರಾ, ಬರೀರಿ, ಬರೆಯದಿದ್ರೆ ಪರವಾಗಿಲ್ಲ. ಆಯ್ತು ಅಷ್ಟೇ ಕ್ವಶನ್ಸ್. ನಾವು ವಿಲ್ ಗೋ ವಿತ್ ಹೀಟ್ ಎಕ್ಸ್ಚೇಂಜರ್ ಡಿಸೈನ್. ಒಂದು ಇನ್ನೊಂದುಂಟು ಗ್ರಾಶ್ ಆಫ್ ನಂಬರ್ ಈಸ್ ಅಂತ ಹೇಳಿ, ಅದು 2016 ಅಲ್ಲಿ ಇಂಥದ್ದೇ ಕ್ವಶನ್ ಬಂದಿದೆ. ನಿಮಗೆ ಗ್ರಾಶ್ ಆಫ್ ನಂಬರ್ ಏನಂತ ಗೊತ್ತಿದ್ರೆ ಸಾಕು, ಸುಲಭನ ಮಾಡ್ಬೇಕಾ ಮಾಡು, ಅದೊಂದು ಹಾಕಿಬಿಡು. ಯಾಕೆ ಸುಮ್ಮನೆ ನಾವು ಇದು ಮಾಡಬೇಕು, ಎಲ್ಲ ಮಾಡಿದೇವಂತ ಆಗಿತ್ತು. 2016 ಹಾ ಹೇಳಿ. ಸೊ ಎಲ್ಲ ಕ್ವಶನ್ಸ್ ಮಾಡಿದ್ದೇವೆ. ವಿ ಹ್ಯಾವ್ ಡನ್ ಆಲ್ ದ ಕ್ವಶನ್ಸ್ ಸ್ಟೂಡೆಂಟ್ಸ್. We have not skipped one single question which comes here. Yes, this has come in 2016. 2016. Yeah. Points first. ಯಾವ ಸೆಟ್ 3 ಬರುತ್ತೆ. ಹೌದು, 2014 ಅಲ್ಲಿ 4 ಸೆಟ್ ಅಲ್ಲ, 2016 ಅಲ್ಲಿ ಹೇಳ್ತೇನೆ ನಾನು ನಿಮಗೆ 2.5 ಲಕ್ಷ ಇತ್ತು. ನಮ್ಮ ಇವರು ಪಾಸ್ ಮಾಡಿರೋ ಯಾರದು ಅಲ್ಲ, 2018 ಅಲ್ಲಿ 2.5 ಲಕ್ಷ. 2018 ಅಲ್ಲಿ 2.5 ಲಕ್ಷ ಹೌದಲ್ಲ, ಮನೋಜ್ ಸರ್ ಪಾಸ್ ಮಾಡಿ 2018 ಅಲ್ಲಿ. 16 ಗೊತ್ತಿಲ್ಲ ಆ ರೇಂಜಲ್ಲಿ ಇತ್ತು. ನಿಮಗೆ ನೋಡಿ ಎಷ್ಟು ಒಳ್ಳೇದು ನೋಡಿ, 70 ಇಲ್ಲ 80,000 ಅಲ್ಲಿ ಬರುತ್ತೆ ಈ ಸರ್ತಿ. ಒಳ್ಳೇದು ಯಾಕೆ ಒಳ್ಳೇದಲ್ಲ? ಇಲ್ಲ, ಯಾಕೆ ಹೇಳಿ, ಇಟ್ಸ್ ರಿಲೇಟಿವ್. ನಂಬರ್ಸ್ ಆರ್ ಲೆಸ್ ಮಾರ್ಕಿಂಗ್ ಹೈ ರ್ಯಾಂಕ್ ಸಿಗ್ತದೆ. ಡಿಫಿಕಲ್ಟ್ ಲೆವೆಲ್ ಎಷ್ಟೇ ಇರಲಿ ಅಪ್ಪ, ಎಲ್ರಿಗೂ ಡಿಫಿಕಲ್ಟ್ ಆಗುತ್ತಲ್ಲ. ಹಾ ಹೌದು, ಡಿಫಿಕಲ್ಟಿ ಲೆವೆಲ್ ಎಷ್ಟೇ ಇನ್ಕ್ರೀಸ್ ಆಗಲಿ, ಇಟ್ ಇಸ್ ರಿಲೇಟಿವ್ ಗ್ರೇಡಿಂಗ್. Numbers are becoming less. So what happens? Previously, for that particular marks, if you were getting 5,000 rank, now you would get 2,500. ನಿಮ್ಗೆ ಏನು ಬೇಕಾ? ಸೀಟ್ ಇಸ್ ಸೇಮ್, ಇಸ್ ಇಟ್ ನಾಟ್? ಸ್ಕೋರ್ ಮೇಲೆ ಕೊಡಲ್ಲ ಅಂತ ಹೇಳ್ತಾರೆ, ಕೊಡಲ್ಲ ಅಂತ ಹೇಳಲ್ಲ. ಗೇಟ್ ಪಾಸ್ ಆದ್ರೆ ಆಯ್ತು. MS ರ್ಯಾಂಕ್ ಅಷ್ಟೇ, MSc ಗೆ ಸೀಟ್ ಇರೋದಷ್ಟೇ, MTech ಗೆ ಸೀಟ್ ಇರೋದಷ್ಟೇ ಎವ್ರಿ ಇಯರ್. ನೀವು ಮುಂಚೆ 5,000 ರ್ಯಾಂಕ್ ತಗೊಳ್ಳೋದು, ಈಗ 2,500 ತಗೊಳ್ತಾರೆ, ಯಾಕಂದ್ರೆ ಜನ ಕಮ್ಮಿ. ಆ ಟಾಪ್ ರ್ಯಾಂಕ್ ತಗೊಳ್ಳೋದು ತುಂಬಾ ಕಷ್ಟ ಹೋಗ್ತೇನೆ ನಾನು. ಸರಿ, ಸೊ ವಿಲ್ ಗೋ ವಿತ್ ಹೀಟ್ ಎಕ್ಸ್ಚೇಂಜರ್ ಡಿಸೈನ್. ಸೊ ಕನ್ವೆಕ್ಷನ್ ಆಯ್ತು, ಫುಲ್ ಕನ್ವೆಕ್ಷನ್ ಒಂದು ಒಟ್ಟಿಗೆ ಒಂದರಲ್ಲಿ ಹಾಕಿದ್ದೇನೆ, ಸಾಕಲ್ಲ. ಪೋಸ್ಟ್ ಕನ್ವೆಕ್ಷನ್, ಫ್ರೀ ಕನ್ವೆಕ್ಷನ್ ಎಲ್ಲವನ್ನು ಒಟ್ಟಿಗೆ ಹಾಕಿದ್ದೇನೆ. ಸೊ ನಾವು ಹೀಟ್ ಎಕ್ಸ್ಚೇಂಜರ್ ಡಿಸೈನಿಂಗ್ ಹೋಗೋಣ, ಆಯ್ತಾ? ಇದನ್ನ ಸೇವ್ ಮಾಡ್ತೀನಿ. ಹೀಟ್ ಎಕ್ಸ್ಚೇಂಜರ್ ಡಿಸೈನ್ ಆದ್ಮೇಲೆ ವಿಲ್ ಗೋ ವಿತ್ ರೇಡಿಯೇಷನ್ ಅಂಡ್ ದೆನ್ ಇಟ್ ಕಂಪ್ಲೀಟ್ಸ್. ಈ ವಾರದಲ್ಲಿ ಕಂಪ್ಲೀಟ್ ಮಾಡುವಂತ ಉದ್ದೇಶ ಇದೆ, ಅದು ನೋಡು. Okay students, we'll start with heat exchanger design. Okay. So heat exchangers. So what is the heat exchangers? We will start with black only, because it is after heat is exchanged, so it becomes black. Now tell me why heat exchangers are required, where it is required, okay, which are the industry which is required heat exchangers. One of the best thing is boilers. Boiler is also a type of heat exchanger. Flue gases are there on one side. You are heating these refrigeration coils is very important. So that is also important. So yeah, refrigeration coils is one of the heat exchangers. Then in power plants, radiator is also a heat exchanger. Okay, so there are a number of things where heat exchangers is there, is it not? Now, first of all, let us see types of heat exchangers. These basic things we know, we have an idea of what is heat exchangers. Okay? Now we'll see classification of heat exchangers in which different ways we will see. Okay? So One of the major classification is types of heat exchange. Types of heat exchange. Types of heat exchangers. First one is called parallel flow heat exchangers, and then the one is called counter flow heat exchange. Parallel flow, parallel flow. Second one, B, is counter flow. How the parallel flow and counter flow works, let us see. So if you have a parallel flow, suppose in case you have, this is the outer pipe and this is the inner pipe. Say this is the inner pipe. Okay. So here it can be hot in and cold out. This is cold out fluid, of course. And here we will have, okay, this is another thing here, right? So we may have cold in, here we have a entrance here, and here may have entrance, okay? So this is cold in and this is hot out, right? Sorry, cold in and cold out. Sorry, this is hot in, hot out. This is cold in and cold out. So the hot fluid is coming in and it is cooling down, but still it's hot only. Okay, cold fluid is going in, it's heating, but still it's cold only comparatively. So that is called a parallel flow. Now what happens here is, if you have the temperature and the length, for example, say this is the length of flow, a flow length, okay? So direction of flow, okay? Length of flow, it is not, yeah, length of flow. If you consider hot fluid will cool down, is it not? So if you consider the hot fluid temperature, so if I say this is temperature, hot fluid will cool down and cold fluid will heat up, is it not? So if you consider the cold fluid, that will heat, correct? This is this line. So cold fluid will heat up, hot fluid will cool down, right? So the line being this, right? Right. So this is how the parallel flow is. If you consider counter flow, same thing, but a bit different. The where it goes in and goes out is different. That's all. So if you consider counter flow, same pipe here, but instead of getting in over here, okay, let us say hot in and hot out. But here the lies difference always lies, okay? So it's like this. Okay. So this here hot in is it. Here we will have cold in and cold out. Cold out. Cold in and cold out. So what is happening counter flow? Okay. So what's happening here is, if you have the temperature versus the distance, this is temperature. This is temperature. Okay. So temperature versus distance. What is happening is, see, hot fluid is going in this direction here, cold fluid is also going in this direction. Correct? But in the other side, what is happening is, if you say this part over here, okay, so we are having a dotted line here, okay, showing that. So now what is happening? Cold fluid or hot fluid is going like this. It's going in this direction, and the cold fluid is coming in this direction. So hot fluid is going in this direction, whereas cold fluid is coming in opposite direction. Observe the directions. So it is flowing counter to each other. Whereas here you see it is going parallel to each other. So that is why it's called parallel flow, and this is called the counter flow. Make sense? Those are the types of heat exchanger. Then there is something called mixed flow, both fluid or cross flow. Okay, so mixed flow, cross flow, both are different. And cross flow and counter. Very different. आराम है, गड़िबड़ी है नहीं. No गड़िबड़ी, गड़िबड़ी बड़ी बड़ी. See the types of shell and tube heat exchangers. There is cross flow heat exchangers and all those things. I want you to refer 3 pages on Senja. I will not do it. Okay? You can refer 3 pages of Senja, which is page number 649 to 651. Refer page 649 to 651 Senja, because it is very simple. You can do that. Very important one. Very important. I'll directly go to overall heat exchanger. Then what you will suggest? Just refer to. Okay. Then he has said different types. There's something called shell and tube heat exchangers. Okay. So there will be set of tubes and there's a shell. Okay. There's hot fluid coming in and going out from the shell, and there are a lot of tubes through which other things. It's very commonly used. Then there are plate heat exchangers. I've told you about plate heat exchangers. Okay, which can be cross flow also, it can be parallel flow or counter flow also. All the things can be there in plate heat exchanger. Then there is plates here like this, and then you have uh, tubes. Okay, so in between plates there are holes where tubes goes, and one fluid goes in between the plates, another fluid goes inside the tubes. This is what is used in ACs. In air conditioner, if you see the other side, that is the type of cross flow heat exchangers. Understand? The fan is there. If you see that, okay. So fan is here. The tubes are going like this, okay, and the flow what is going is in the other direction. That's called cross flow heat exchanger. This is parallel flow and counter flow. But if you consider our AC air conditioner how it is, you have a lot of plates very closely spaced. If you see, closely spaced, and then there is tubes which goes inside this, right? ಈಗ ಟ್ಯೂಬ್ಸ್ ಇರುತ್ತಲ್ವಾ, ಈ ಟ್ಯೂಬ್ಸ್ ಒಳಗಡೆ ಹೋಗಿ ಹೀಗೆ ಬರ್ತಾ ಇದೆ ಒಳಗೆ. If you see the AC, this lots aluminum plates are there. You will see same thing on the evaporator side. Try to, if you have AC at home, try to service the AC by yourself. Never done it? Done it, no? Then I have done it a lot of times. Ah, ಹೌದು ಮಾಡ್ಬೋದು, ಆರಾಮಾಗಿ ಮಾಡ್ಬೋದು. ವಿಂಡೋ ಎ ಸಿ ಅಲ್ಲ, ಇದ್ರಲ್ಲಿ ಕೂಡ ಸ್ಪ್ಲಿಟ್ ಎ ಸಿಯಲ್ಲಿ ಮಾಡ್ಬೋದು. ಹೊರಗಡೆ ಇದಿರೋದು ಏನು ಹೇಳ್ತಾರೆ, ಕಂಪ್ರೆಸರ್ ಇರೋದು, ಒಳಗಡೆ ಇವ್ಯಾಪರೇಟರ್ ಇರುತ್ತೆ. ಹಾ, ಅದರಲ್ಲೇ ಫಿಕ್ಸ್ ಇರುತ್ತೆ. ಸೊ ಇವ್ಯಾಪರೇಟರ್ ಟ್ಯೂಬ್ಸ್ ಆಲ್ಸೋ ಗೋಸ್ ಓವರ್ ದಟ್, ಏರ್ ಇಸ್ pushed. Only then you get that air, is it not? Because over the evaporator tubes, the air goes, and the evaporator which has cold refrigerant, okay, is going in the tubes. Over that, through there are rollers. If you see that rollers, that rolling fans are there, which are small fins. It's running like this, and that pushes the air over that particular. And then there are some plates where dust clearance is there, is happening. Okay, and the dust is put like this generally. Okay, dust, a shield, so that dust, whatever is there, it's not going inside. So like that, it pulls the air. Good. Okay. Just observe. I hope everybody has. How many of you don't have AC in the home? You don't have. You don't have. Okay. You are in cool places. Okay. I also don't have. But in the previous home I had. In previous this one also I have. Okay. I used to show it. The last in Besant complex, it was air conditioned classroom. Okay. And it was very uncomfortable. Let me tell you. Okay. Why it is uncomfortable? Because you used to feel hot at once sometimes. Okay, when it is very hot, no, it's not enough basically. It's this big 1.5 ton was there. Okay, but still sometimes. Okay. Shane did not attend that class. Nobody is there who attended that class. The Bezen classroom, no, you did not. Okay, so then you understood about cross flow, as well as uh, yeah, parallel. Yes. It's shell and tube detection. They're also called. Correct. Yeah. So here it is about how you consider it. Okay. So I understand. I understand. There are baffles there. Observe here. What happens? You're talking about baffles. Okay. So what is happening here is the shell and tube heat exchanger. If you see, is a shell which is the most commonly used one. Okay. There'll be one tube which this is out. This is a shell. Okay. And this is the other side of the shell. So maybe you have one fluid coming here, other fluid going out here, right? So this is how the shell works, is it not? And then you'll have a lot of tubes here. Correct. There are a lot of tubes, right? Right. This is how it is. And then what happens? You have baffles here to actually stop. It's a plate actually. which tries to show how the fluid will go, right? So if you see the fluids how it is, okay, the way it goes is, okay, so we'll have two sides, okay, one is shell outlet and tube outlet, two things are there. So tube will go like this. I will talk about tube. This is shell outlet, and here you'll have shell inlet, shell inlet, shell outlet. So tube inlet and tube outlet. This is tube inlet and this is tube outlet. Okay, and then here you have shell inlet. This is shell inlet and this is shell outlet. Now what is happening here? This is considered as counterflow. Although inside what is happening is, inside this goes like this. It goes inside maybe in between here like this. This is shell inlet, goes like this. And because of the baffles, because of the baffles, okay, yeah, yeah, this is shell inlet. Oh, 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 oh. Baffle only connects so tube inlet. I guess. This is how in the tube it goes. These are tubes, okay, and then it comes out. Here, baffle what is done is he keeps it like this. So what happens after this? It is taken down like this. Then it goes like this. Then it goes this way. And then it goes this way. This is how the shell is. Now, will you call it cross flow and counter flow? Okay, we generally call it counter. Although you are correct, here you have some places you have this one direction is there, cross direction is there, but generally what you see, this is the shell which is there, this is the tube which is there, which goes counter to each other. That's how it is. Yes. That's what we can see. Okay, that's what is the convention. Okay, so like that. Okay, but otherwise if you see there is cross flow also, there is parallel flow also. Cross flow is it's going like this. The flow is like this. The top, the best example is AC. You have a cross flow there. Okay, AC duct and those uh, car radiator. Yes, car radiator is the best example. That's also one of the examples. Okay, then what examples you have for cross flows in H H HVAC? Say that. Say HVAC, okay? Heating, ventilation, and air conditioning. Okay, that is HVAC. Okay, HVAC. Okay, I understand. Okay, HVAC. I did not remember. HVAC is a, so in HVAC systems. Okay, you have cross flow, yes, but not that always it is cross flow. There are other things also, but generally it's cross flow. Yeah, because you use thin aluminum plates, and you have these refrigerants going over there. So things are not that complicated as you think. Okay, sure. Then, right. Next one. Now let us go with the overall heat transfer coefficient, which we have done already. We will do it again. Overall heat transfer coefficient. Small topics, so let us complete it. And then we will go with Pauling. See, generally when there is a tube, it is we had already done. You have a tube here, okay, and this is hot fluid here. So let us say this is hot fluid. It has a thickness which is so thick. This also has some thickness. Okay. And in between, you have say, we'll use this liberally. Okay. So let us say hot fluid. So this is hot fluid, and then so this is hot fluid, and then you have a cold fluid also. So we'll have a cold fluid. So we have cold fluid, which is moving inside. This is also moving, whatever be that is. Okay. So now if you consider the wall between hot fluid and cold fluid, if you consider a wall between hot fluid and the cold fluid, okay. So what we will have, heat transfer is happening to this region. This is the heat transfer direction, correct? So here from the hot fluid, the temperature is high, it goes down, and this is the wall, and then it goes down, and then it comes here, and then goes to T infinity. Okay, this is T infinity. This I will say it is uh, T inlet, the center of that Ti, I'll say inside. Okay, Ti. So we have that. So we have on one side we have hot fluid. So on this side you have hot fluid, and on this in this periphery inside we have the cold fluid. So this is the cold. Makes sense. So that is the temperature how it is changed. So here on the cold fluid side, okay. So you have a lot of things here. Okay? So here in this particular thing you may have, so there might be Ti, there may be Ti. Everything whatever we have studied, we are implementing it here. Then we have then you have another one. Then resistance of the wall. Then you have another fluid here, and then we will have T infinity. Here there is another resistance, convective resistance. So this is T. So here we have Ri, which is equal to 1 by Hi Ai, right? And here we have R wall, right? And here we have R O, R naught, R outside is equal to 1 by H naught A naught. Now R wall is equal to log of D naught by D naught by Di divided by 2 pi Kl. Agreed? Now R is equal to R total. R is equal to R total, which is equal to Ri plus R wall plus R naught. Right? This can be equal to 1 by Hi Ai plus log of D naught by Di divided by 2 pi Kl, which is the length, plus 1 by H naught in simple. I leave D naught by Di. Is it wrong? 2 by Kl. I wrote it. What I'll convert into R if you want. I'm making fun of you actually. Okay. So T I will use, okay, for your case I will take T R naught plus, no, okay, R naught plus 2 Ri. It will come the same, is it not? Sometimes it's good to make fun. Is it? Okay. So that next one, Q dot is equal to delta T by R, right? Which can be equal to also U A of the surface, which can be any surface, into delta T. can also be equal to UI, overall heat transfer coefficient I, AI delta T, which can be equal to U naught A naught delta T, where UI, U naught and US are overall heat transfer coefficient. Overall heat transfer coefficients. Makes sense. Just by putting color, it looks so beautiful, is it not? It's the same thing. My handwriting is as bad as always. US is US. US is United States. This was fun of myself. I did not put US here. Sometimes when you make fun of others, you should make fun of yourself. Otherwise, others will feel bad. Correct. Right now, any surface, any intermediate surface. Why this is required is because sometimes there is something called fouling which happens. Let us see about fouling later. Maybe today we will not do, tomorrow we will do fouling. Okay, which is common in industrial heat exchangers. The ways to remove that. Yeah, here's one. You think what would be the next step? What's the way to substitute? R, yes, is it not? So, yes, will do. So, delta T cancels. 1 by R if you do, that's right. Okay. So, shall I move? Shane? So, now, here what happens? So, 1 by US any surface, area of any surface is equal to 1 by UT, sorry, UI, where is UT? UI, AI, right? UI, AI. UI AI is equal to 1 by U naught A naught is equal to R, which is equal to 1 by HI AI plus R wall plus 1 by H naught A naught. Very important. I did a mistake yesterday. I should not repeat it. Okay. The mistake I did was I did not name. Is it not? So let us name it first. Okay. So let this be equation number 1. Okay. Not this. Okay. So note UI AI is equal to U naught A naught is equal to US AS. But UI is not equal to U naught is not equal to US. I hope you have realized that. Correct? ಅರ್ಥ ಆಯ್ತಾ ಇದೆಯಾಕಂತ? Yes or no? No. See here, R is the same. If R is the same, US AS, UI AI, U naught A naught should be the same. But is UI equal to U naught is equal to US? No. Because AS is different, AI is different, A naught is different. Make sense? How does this come? Why does this come? Because we have to see how does it come. This is done by the equating the Fourier law of heat conduction to Newton's law of cooling. This Newton's law of cooling, this is H A delta T, is it not? Instead of H, I say U, overall heat transfer. So this is equivalent to H. Make sense? See, Fourier law of heat conduction, what is that? Q is equal to delta T by R. What is Newton's law of cooling? Q is equal to H A delta T. Now this, instead of H, I am writing U. That's it. Make sense? So I hope you understood the importance of note, right? So when the resistance of wall is small, which happens when the conductivity of the wall material, when the conductivity of wall material is high, or the thickness of the wall is small, then we can write 1 by U is almost equal to 1 by Hi plus 1 by H naught. If wall thickness is small, okay, okay, if wall thickness is small, then this will be A. If wall thickness is small, then I'll write it. This is A naught, U naught, A naught, or UA is equal to HAI. This is HA naught, okay. But when wall thickness is small, then 1 by U is almost equal to 1 by Hi plus 1 by H naught. This you write it as equation number, and we will stop it here. Okay. Tomorrow we will see some more. We will talk about finning. We will talk about fouling. We will talk about other heat exchanger analysis. We will see LMTD, which we have already seen. Yeah, wall thickness is small, then A naught is almost equal to A naught. AI, is it not? Then you can cancel. So yeah. Okay, done. Chalo. Thank you, students. So next there are some more things. Heat exchangers we have started. Good. Then we will see some more heat exchangers. Maybe 2 or 3 days we'll complete heat exchangers. 2 days we'll complete. By Wednesday, heat exchanger is complete. Radiation we will start from Thursday. Problems on heat exchanger, completing heat problems on heat exchanger will complete. We will not leave one problem. Okay, don't worry. We will leave the problem if you say, sir, enough, sir. This much is enough. Or The questions are exhausted. No more gate questions. Then we'll start. Then, so we'll wait for our